carbohydrate. What are carbohydrates? Carbohydrates are the hydrates of carbon, including sulfur, oxygen, hydrogen, nitrogen, etc. Hydrates of carbon, as the name indicates. The base skeleton part is carbon, hydrogen and oxygen. These are main biological system compounds or molecules. They produce heat and energy for biological system. On the basis of carbon numbers, if we discuss about its classification, then there are different types according to which we classify the carbohydrate. According to the number of carbon, it can be classified as, if there is 2 carbons present in the base, then it will be say diols. And if there is 3 carbon, triols. If 4 carbons are present, then tetrols. If 5 carbon, then pentols. If 6, then hexose. And if 7 carbon, then known heptose. And on the basis of functional group, there are 2 main groups which are present in it. One is CHO, that is aldehyde, and other one is CO, that is ketone. On the basis of functional group, they are further classified into aldoses and ketoses. If we come on diols, then there will be possibilities of only aldones, no ketones, because in aldoses there will be first carbon is of CHO aldehyde group and the last carbon will be primary alcohol. Last carbon is primary alcohol. And in ketoses there will be first carbon is primary alcohol, secondary will be ketone group, and the third will be also primary alcohol. So on this base, there is no ketones present in diols, only aldose. The name is glyceraldehyde, and the structure will be CHO CH2OH. This is the aldehyde group and primary alcohol. In triols, there is possibilities of aldose and ketones both. The aldose will be glyceraldehyde, CHOOH, then CH2OH. This is glyceraldehyde and CH2OH, CO and CH2OH. It is dihydroxyacetone or ketone. Also in tetrose, both are possible, aldose and ketose. In pentose, also aldose and ketose. In pentose, which sugar? As we know, carbohydrates, all carbohydrates are sugars. These are deoxyribose sugar, and ribose sugar. participate in the formation of genetic material which is DNA and RNA. DNA and RNA. As the name indicates, deoxyribonucleotide. And the RNA is ribonucleotide. Ribonucleic acid, and the presence of ribo sugar and nucleotides, deoxyribo sugar and nucleotides. And when we come for hexose, they are the common carbohydrate. Aldose and ketose. For aldose, the example is sucrose, the common sugar. Sorry, this is glucose. And the ketose is fructose. Dextrose is erythrose and erythrulose. And in fructose, pseudohextrose, and for ketose is mannitose. As we know, hexose are the common sugars which generally found and participate in all reactions of biological systems. The structure will be CHO, CHOH, CHOH, and the last carbon will be CS2OH. This is glucose. And if we discuss about the structure of fructose, then it will be CS2OH, CO, CHOH, again CHOH, and the last will be CS2OH. This is fructose. It is the classification according to the number of carbons and on the basis of functional group, that is aldehyde and ketone. Now, again type of classification, that is reducing sugars and non-reducing sugars. It is based on the free functional groups present in any sugar, then it will say the reducing sugar. All sugars are reducing except sucrose, because sucrose forms alpha 1 beta 2 bond and there is no functional group free for reaction. Then you can say the another type of classification, it is on the basis of reduction. This is reducing sugars and non-reducing sugars. All sugars are reducing except sucrose. Only sucrose is the one which comes in non-reducing sugar. Another type of classification is on the basis of monosaccharide molecules is present in carbohydrate. As we know, monosaccharide is the single unit of carbohydrate. Mono means single. Then oligo, more than 2. And the last one is polysaccharides, more than 5. Monosaccharides, the example is all the simple simple or single unit of carbohydrates, that is glucose, fructose, glyceraldehyde, dihydroxyacetone. And in oligosaccharides, the joint of two carbohydrates by the glycosidic bond. The bond which join two carbohydrate monosaccharide units, that is known as glycosidic bond. This is glycosidic bond. And these are the monosaccharide units. If single unit present, then monosaccharide. If more than 2, then oligo. 2 to 5 numbers are present of monosaccharides in the structure, then we will say oligosaccharide. If more than 5, it will be 300, 500 or etc. Then it will be polysaccharide. In polysaccharide, the further classification is homopolysaccharides and heteropolysaccharides. As we know, homo or same monosaccharide units are present, and in hetero, different monosaccharide units are present for the formation of polysaccharide structures. Now, as we know, there is some type of isomerism in carbohydrates, also in organic compounds. They show the isomerism. Different types of isomerism. First one is structural, and second one is stereoisomerism. And again, stereoisomerism are further classified into three parts: optical, geometrical, and conformational. But in carbohydrates, the isomerism present is optical isomerism. Due to the difference of optical activity, and the isomers are called optical isomers, which are mirror images of each other. For example, glyceraldehyde. These two structures are the mirror images of each other. If the OH of second carbon is present towards the right hand side, then we will say deformed or dextro-rotatory. Dextro-rotatory form, right hand side form, or clockwise form. And if the OH of second carbon is present towards left side, it will say the L form or levorotatory or left hand side or anti-clockwise. Anti-clockwise form of the molecule. As we see here, these are the same structure formula, but difference is the presence of OH group, which are right hand side and left hand side. These are also known as enantiomers. One term is enantiomers, and one more term is diastereomers, diastereoisomers, anomers, which are not mirror images, these are different D and L form. These are different conformation. Now, enantiomers and isomers. If we talk about glucose, fructose and mannose are the isomers of each other. As we know, the structure of fructose is CH2OH, CO. the last one is CH2OH. This is the fructose. And the structure of glucose, CHO, CHOH, and last one is CSOOH. In mannose and glucose, there is only the difference of groups, functional groups of second carbon. This is glucose, this is mannose. These are the structural isomers. And these are the stereoisomers or stereoisomers of each other. Now, on the basis of these structures, we better understand about the isomerism or isomers, which is structural isomers and which is stereoisomers. Only the difference is in structural formula, not in empirical formula or general formula. Just C6H6, C6O6H12. In all the three, there is a formula is C6, H12 and O6. But the difference in structural formula is functional group. And in stereoisomers, the position of functional group. Now it is about the classification of carbohydrates. So there is a different types of classification on the basis of number of carbon present in the carbohydrates, on the basis of sugars, it is reducing or non-reducing, on the basis of functional group, is it aldehyde or ketone, or on the basis of monosaccharides units. If single unit, then monosaccharide. If more than 2 means 2 to 5, then oligosaccharide. And if more than 5, it will be 300, 500, as it is, it will be polysaccharide. And the again classification of polysaccharide is homopolysaccharides and heteropolysaccharide. Means homo means same polysaccharide units are present, and in heterosaccharide there is a difference in monosaccharide units are present in the formation of structure of the polysaccharide units. I hope you will better understand about the classification of carbohydrates.